The third way to find a solution for a system of linear equations is by the addition method, which is also known as the elimination method. And here's what you do. You want to, number one, write the equations one under the other so that the like terms are aligned. Eliminate one variable. If necessary, put an asterisk by that. If necessary, multiply both sides of one or both equations by an appropriate number so that the coefficients of one variable are opposites. Add the new equations to form a single equation in one variable. Solve the equation. Number 3, substitute the value found in step 1 into either of the original equations and solve. Check your answer. Alright, so we have here example 5. Use the addition method to solve the systems of linear equations. State whether each system is consistent, inconsistent, or dependent. So let's look at an example. We have here x minus 5y equals to negative 12, and we have negative x plus y is equal to 4. So, what makes this one a little bit different than the first, the substitution? Well, with substitution, we're taking an expression and we're substituting it back into an equation. This, the addition method, also known as the elimination method, what we're doing is we're lining up our variable terms of x and y in our constant terms so we can eliminate a whole variable if possible. So, with this type of method, what you want to look for variables that have the same coefficient, same numbers. And then if they have the same coefficient, you want them to be opposites, meaning one is going to be positive, one is going to be negative. So as we look at example A, look at your variable term of x. Our first equation, you have a positive x. Our second equation, you have a negative x. Well, see, that will cancel out. Then, adding up and down, because that's where it says aligned, look at your y's. We have negative 5y plus y. We have negative 4y is equal to negative 12 over 4, which gives us negative 8. And then we solve. Our goal is still to find an ordered pair. We have y is equal to negative 8 divided by negative 4. That gives us positive 2. So we want to find, it says we're looking for an ordered pair, if possible, because it's saying state whether if the system is consistent, inconsistent, or dependent. So our y coordinate is 2. So if we have, let me say this, if we have a system that is inconsistent or dependent, okay, and we're going to do an example of one, then we're not going to have an x or y. And I'll show you an example. Let's find x. So we're going to go back. We're going to go back and substitute to find the other variable. So we're going to substitute 2 in for y. We have x minus 10 is equal to negative 12. We're going to add 10 to both sides, and we have x is equal to negative 2. So when we have a solution, one solution is a consistent system. They're going to intersect at negative 2, 2. Alright, let's look at another example. We have here x minus 2y equals to 4, and we have 2x minus 4y is equal to 4. Now we're going to go back to step 2 especially the part that says, if necessary, multiply both sides of one or both equations by an appropriate number so that the coefficient of one variable are opposites. Now, as we look at this and how example B differs from example A, is that we don't have a variable where we have a coefficient of 1, or that we have the variables that are the same. Look at your variable x, your x variables, or the coefficients of the x. We have the first equation, we have a 1. The second equation, we have 2. Then for y, first equation, we have a -2. The second equation, we have a -4. So what we have to do is decide which variable do we want to eliminate first. Is it the x or the y? Well, if we want to eliminate the x, we need to find the least common multiple that will give us the same coefficient. Well, I want my first equation, x, to be a 2, because the least common multiple for 1 and 2 would be 2. But it also has to be -2 because we want to cross out the variable x. So we're going to multiply the first equation by -2 on both sides. And then we have, and we're going to distribute -2x plus 4y is equal to -8. There's no need to change the second equation. Now, sometimes you may have to change the second equation as well if it doesn't come out the way that you want. You want your LCM to be the same, so we may have to change maybe one equation or both equations. So we have 2x minus 4y is equal to 4. And look, your x variables cancel out. The y's are canceling out. So we have 0 on the left-hand side is equal to -8 plus 4, which gives us -4. Now, as we look at this, 0 is equal to -4, that we're not solving for a variable. We know that that's not true. So what type of system where you don't have a solution? Okay? Well, that's an inconsistent system, which has no solutions. Okay? In our last example, we have here x minus 3y is equal to 2, and we have 5x minus 15y is equal to 10. Alright, so we don't have any variables that will have identical coefficients. We don't have any variables that are opposites one of each other. So at this moment, we need to decide which variable do we want to eliminate first. Well, since we've gotten rid of the x's first for the first two examples, let's look at the variable y. We have a constant term of -3, constant term of 15. Well, the least common multiple for 3 and 15 would be 15. So our goal is to have that first equation, the -3y, to become 15y. And we want it to be positive 15y because we want the y's to cancel out. Therefore, we're going to take the first equation and we're going to multiply by -5 to both sides. And we're going to distribute. So our first equation, -5x plus 15y is equal to -10. Then our second equation stays the same. And let's look. The x's cancel out, the y's. That gives us 0 on the left-hand side. What do we have on the right-hand side? 0 as well. So we have 0 is equal to 0. So when this happens, if you were to graph it, this would be, you will have parallel lines. Okay? Excuse me. Not parallel lines. We will have lines where they are identical. They're the same identical line, one line on top of the other. So we will have what's called a dependent system, and it has all real numbers, infinite numbers. Okay? And those are the different types of systems that we've covered in this course. Let's look at one more example. We have here 6x minus 3y is equal to negative 3. We have 4x plus 5y is equal to negative 9. Alright, so I'm looking to see if I have any variables that will have identical coefficients. We don't have anything. But do I see a variable that has a positive and a negative? Well, we do. We have the variable y. Well, we want to make sure, our goal is to have the y's have the same coefficients. So we're going to multiply, this time the first and second equation. What's the LCM? These come a multiple for 3 and 5. That is 15. So we're going to times the first equation by 5 and the second equation by 3. So our new equations are, first equation 30x minus 15y is equal to negative 15. Then our second equation we have 12x plus 15y is equal to negative 27. Now our y's cancel out. Add your x's. We have here 42x is equal to negative 42. We're going to divide by 42 to both sides, and we have x is equal to negative 1. Now let's substitute to find the other solution. Let's go back to the original equation. It doesn't matter. We're going to substitute negative 1 into the first equation for x. So 6 times negative 1 minus 3y is equal to negative 3. We have negative 6 minus 3y is equal to negative 3. Add 6 to each side. We have negative 3y is equal to 3. Divide by negative 3. We have y is equal to negative 1. So our ordered pair is negative 1, negative 1. And we have a consistent system because we have one solution.